AP Calculus BC, Unit 7, Day 12, office hours. Little extra review if you'd like to get ready for your test. Graphing calculator problem. So it says baker is creating birthday cake. The base of the cake is the region R. In the first quadrant under the graph of y equals fx. And fx equals 20 sine pi x over 30. The period of that would be 2 pi divided by pi over 30, which would be the same thing as 2 pi times 30 over pi, which would be 60, which totally makes sense with this graph. It has an amplitude of 20. Okay, it says the region R shown if the derivative of f is given. Fine, cool. We could have done that ourselves pretty easily, but we'll take it. A says the region R is cut out of a 30 by 20 foot centimeter rectangular sheet of cardboard, and the remaining cardboard is discarded. Find the area of the discarded cardboard. So if you look at this, 20 by 30, perfect rectangular shape to cut the sheet out of, and we want to figure out the discarded area. So I think our best strategy would be to find the area of the rectangle, 20 by 30, and subtract the area under the curve. That we could integrate by hand, but might as well use our calculator to do it. It'd be a lot quicker and probably less free of errors. 0 to 30. So let's type that in our calculator. That's a setup, which is this is worth 2 points on its own. And the point breakdown here is 3, 3, 3. So if we do 60 minus math 9, 20 sine pi x divided by 30, comma x, comma 0, comma 30. Ooh, that doesn't make sense. Oh, should be 600. So I'm going to insert 600. Doesn't make sense to get a negative area. Okay, so are there any units? Centimeters squared, it's area. So the answer is a point. That's the discarded area. B says the cake is a solid with base R. Cross sections perpendicular to the x-axis are semicircles, so this is volume by cross section. We can draw one slice. Okay, volume by cross section. So the volume is going to be some integral of area in terms of x dx is the thickness, gives you the volume. They're going to be half circles. They're going to be 1/2 pi r squared. So our limits are going to be 0 to 30, pi over 2. This is the diameter, which is y top minus y bottom. So y top, y bottom is just 0. So it's really just the y coordinate of this curve, right? So it's going to be 20 sine pi x over 30, all divided by 2 squared. So that's our setup. And so we're going to do, we can move the pi over 2 out front if you want. Math 9, 10, now we should put this all in parentheses. 10 sine pi x divided by 30, close, squared, comma x, comma 0, comma 30. And let me see, did I even finish? I didn't even finish reading this. It says, the baker uses 0.05 grams of unsweetened chocolate for each cubic centimeter. How many grams of unsweetened chocolate will be used? So this is the volume, and I'm going to keep some extra decimal places. That's the volume. I guess I should write right here. It's cubic centimeters. So if it's 0.05 grams per cubic centimeter, we would then multiply it times 0.05 grams per cubic centimeter. And we would get 117.809 or 117.810 grams of unsweetened chocolate. Will be used for the cake. Okay. C says find the perimeter of the base of the cake. Oh, cool. That's totally a BC thing because that's arc length. And so we have to get the length of that curve, which is going to be 0 to 30 of the square root of 1 plus the derivative, which they gave us, squared dx, plus the length along the bottom is just 30. So we got to make sure to add 30. So it's going to be 30 plus math 9 square root 1 plus parentheses 2 pi over 3 parentheses cosine of pi x divided by 30, close the cosine, close that, around that whole thing, close that, squared, close the square root, comma x, comma 0, comma 30. That should hopefully be it. And we get 81.803 or 81.804 centimeters length, one dimension. So that's it. That's that problem right there. This was 2 points on this part. Then your answer was 1 point on the previous part. This was 2 points. The setup here, and then the answer was 1 point. So there you go. Not too bad. Did that in half the time, 15 minutes. Okay, let's take a look at the back. Right away, I know we're going to be using estimation techniques because they gave us a table. So Riemann sums, trapezoids, estimating derivatives. This also looks like potentially a rate model problem or something like that, a tank, something like that. Figure above shows above ground swimming pool in the shape of a cylinder with a radius of 12 feet, height of 4 feet that's the height of the pool. So the height of the water. The pool contains 1,000 cubic feet of water at time 0. So the amount at time 0 is 1,000. Initial condition. During the time interval 0 to 12, water is pumped into the pool at a rate of PT, that's what the table is. The table above shows the values of PT or selected values of T during the same time interval water is leaking out at a rate of R, and they give you the equation for R. The volume V of a cylinder with a radius of R and height h is pi r squared h. You guys should know that. A, use the midpoint Riemann sum with 3 subintervals of equal length to approximate the total volume of water that is pumped into the pool, 0 to 12, just that. So we're trying to integrate the incoming rate, which is PT, from 0 to 12. We're going to estimate it with midpoint Riemann sum. So there's 3 subintervals, so that would be 4. That would be your subintervals right there. So I'm going to draw a little picture to help me organize this information. 0, 4, 8, 12. Bases are 4 each. My rectangles. At 0, it's 0. At 4, it's 53. Oh, we need to find actually the values at the middle are going to be our heights. So at 2, it's 46. At 6, it's 57. And at 10, it's 62. So those are going to be the heights of our rectangles. So we got to show the work, show the setups. 4 times 46. That picture's not going to help you, but this is stuff you have to write down. 4 times 57. 4 times 62. I mean, we have a graphing calculator, so we don't have to, calculate all these by hand. We could just do it on our calculator. So 4 times 46 plus 4 times 57 plus 4 times 62 is 660. So 0 to 12 of PT dt is approximately 660. The units of this should be cubic feet of water. This is the amount of water pumped in. So pumped in to the pool during the time interval 0 to 12 hours. A little nicer answer. Okay, B says calculate the total amount of water that leaked out. Well, that's going to be the RT dt 0 to 12, and we don't have to estimate this. We have a calculator. I mean, if you really want to, you could do this by hand, but I don't recommend it. I think it'll run out of time. So we can just do this in our calculator. Math 9, 25, e to the negative 0.05, x, close, comma x, comma 0, comma 12, 225.594 cubic feet leaked out of the pool during the time interval 0 to 12 hours. Okay. C says use the results of part A and B to approximate the volume of water in the pool at time t equals 12 hours. Round your answer nearest cubic foot. Okay, so watch out for that. Usually we do 3 decimal. Actually, this time we do nearest cubic foot. Now this is a rate model, right? So the amount at 12 would equal the initial amount, which they said was 1,000, plus the interval of what was pumped in minus the interval of what leaked out. So A12 is going to be approximately, this is exact, but this is an approximation, 660 minus 225.594182. I'm going to carry extra few decimal places I still have in my calculator. So the amount at time 12 is approximately, that's going to be, so we do 1,000 plus 660 minus the previous answer. We get 1434.405 or 1434.406. Now, if you hadn't carried these extra decimals here, you would have just got 1406, which is fine, but that's the rounded answer, and you kind of get lucky. So that's cubic feet of water. D says find the rate at which the volume of the water in the pool is increasing at time t equals 8. How fast is the water level in the pool rising at t equals 8 hours? Indicate units and measure in both answers. So we're looking for the rate of volume, which is A prime, which is going to be PT minus RT. So A prime at time 8 is going to be P8 minus R8. It's good to write this stuff. This is like the setups. Now, I don't really want to, I don't know. I kind of wish I put these in my Y menu. I'm going to go and do it right now. I probably should have just done it from the beginning. Well, P8 is actually in the table. That is 60. And then R8, whatever, we could just do it on the home screen. It's going to be 25 e to the negative 0.05 times 8. So 16.758001115. And so I'm going to do 60 minus the previous answer, 43.241 or 43.242. That's the rate. And that's going to be cubic feet per hour. It said indicate units in both answers, so you better have your units. Okay, and then it says how fast is the water level in the pool rising? I would call that like the height of the water in the pool. So we're looking for dH dt, which is right away making me think this is like related rates, because we got volume equals pi r squared h, which the radius is constant, it's 12. So it's 144 pi h. dv dt equals 144 pi dH dt. We want dH dt. We just found dv dt, right? We just found that. So that's 43.241998885. And it should, because the volume is increasing at that point, the height should be increasing. So then we solve for dH dt by dividing this answer by 144 pi in parentheses. And we get 0.095 or 0.096. And the units are feet for height per hour. It's a rate. So little related rates thrown in there right at the end. Okay, well, that's it. Some good stuff in there. Rate models, estimation techniques, area of volume by cross-section length got thrown in there. All right, be ready for your test.